Good evening and thank you for tuning into this video. So right now we have been talking about inequalities. So tonight we are going to see how inequalities can be used to solve word problems. And I'm going to work two particular types of word problems for you tonight, and then you'll have a chance to practice more tomorrow. So the first word problem reads, Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 in the account by the end of the summer. He withdraws $25 each week for food, clothes, and movie tickets. How many weeks can Keith withdraw money from his account? So first, I'm going to underline important information. So he has $500 at the beginning of the summer. That's important. So he has $500 to start with. He wants to have at least $200 by the end of the summer. So at least $200 is another important part. My last part is that he withdraws $25 each week. Okay. Now I'm trying to figure out how many weeks can Keith withdraw money from his account. The first thing you want to do after underlining or highlighting important parts is you're going to want to define your variable. I'm trying to solve for how many weeks Keith can withdraw money from his account. So I'm going to let X equal the number of weeks. So to name your variable, you just have to look at what you're solving for. So I'm going to let X equal my number of weeks. Now, I like to work backwards on this one. So at the end of the summer, he wants to have at least $200. So I know that my 200 is going to be on one side of my inequality. So I'm just going to put down the 200 right here. Okay. Now he wants to have at least $200. So he doesn't want less than $200, but he wants $200 or more. So $200 is going to be the least amount that he can have. So my sign is going to go like this. And I'll explain more in a second. Okay? So I have one side of my inequality on my inequality symbol. So whatever amount I have up here, I want it to be more than or equal to $200. So I want my less than symbol pointing, I want my triangular part pointing towards the 200 because I want $200 or more. So the other side of the equation needs to be either 200 or greater than that. So now I got to think about what my other side of the inequality would be. So I have $500 to start out with, and then every week I'm going to withdraw $25. So my amount is going to be 500 minus, because I'm going to be withdrawing money every week, so minus 25 times however many weeks that I end up withdrawing. So it's going to be 500 minus 25x. And that's going to be my inequality. So this amount right here at the end of the summer needs to be greater than or equal to 200. So we want to figure out how many weeks can Keith withdraw money from his account and still have more than or equal to $200 in his account. Now I just have to solve for X. So I'm going to subtract 500 on both sides. Okay. When I subtract 500 on both sides, I should get negative 25x is greater than or equal to negative 300, because 200 minus 500 is negative 300. Now I have to divide both sides by negative 25. So since I'm divided by negative, I got to flip the sign. So it's going to be x is less than or equal to negative 300 divided by negative 25 is just 12. So Keith can withdraw money from his account for 12 weeks. After 12 weeks, he's going to have less than $200 in his account. So my final inequality is going to be x is less than or equal to 12. Now, since this is a word problem, I need to write my final answer as a sentence. So my final answer is going to be Keith can withdraw money from his account for 12 weeks. So Keith can withdraw money for 12 weeks. I'm sorry this is so sloppy, but I'm trying to write sideways. But I think you get the idea. So this will be my final answer. So to recap, first I defined my variable. Then I had to set up both sides of my inequality. I want to end up with at least $200. So I have $200 on one side, and I want my other side to be either equal to or greater than $200. Now on my other side, I found 500 minus 2x because I start out with $500, and then I withdraw $25 for each week. So on my left side of the inequality, I'm going to have 500 minus 25x. So 500 minus 25x is going to be greater than or equal to 200. I solve for x and I get x is less than or equal to 12 weeks. So the maximum amount of weeks that Keith can withdraw money and still have at least $200 in his account is 12 weeks. So my final answer is Keith can withdraw money for 12 weeks. After 12 weeks, he's going to have less than $200. That's my first example. Let's work example 2. Example 2 is very similar to example 1, only now we're going to be talking about a taxi cab. Okay, let me just try to get this lined up right. Okay, there we go. So the question reads, yellow cab taxi charges $1.75 flat rate in addition to 65 cents per mile. So Katie has no more to spend than $10 on a taxi. We want to figure out how many miles can Katie travel without exceeding her limit. Okay, so once again, let's highlight my important information. So we have a $1.75 flat rate, and we're also charged 65 cents per mile. Now Katie has no more to spend than $10. So the most money she can spend is $10. So whatever she spends on her taxi has to be either equal to $10 or less than $10. So let's go ahead and write this out. So my amount is $10. That's all I have to spend. So that's going to be one side of my inequality. Okay? Now $10 has to be either greater than or equal to than whatever money I spent on my taxi. So my inequality symbol is going to look like this. Because again, $10 has to be greater than or equal to whatever's on this side. Now I just got to figure out the left side of my inequality. So the yellow cab taxi charges $1.75 for a flat rate plus 65 cents per mile. Okay? Now I jumped the gun a little on this one. I didn't quite define my variable yet. So let's go ahead and define my variable now. My variable is going to be, so I'm going to let x equal number of miles. Again, I should have defined this in the beginning, but I kind of got a little enthusiastic. So let's start all over again. So I'm going to define x as the number of miles Katie can travel. So x is equal to number of miles. When I'm thinking about my inequality, I know that I cannot exceed $10. So however much money I'm spending on my taxi has to be less than or equal to $10. Okay, so that's how I got this part of my inequality. Now I have to determine the left side of my inequality. So to figure that out, I know that the taxi cab charges $1.75 flat rate. So I'm going to put that there first. So I'm going to get charged $1.75 no matter what. In addition to that, I'm also going to be charged 65 cents per every mile. So the total cost of the taxi is going to be the flat rate, $175, plus 0.65x. So 65 cents per every mile. Now I can go ahead and solve for x. So first thing I'm going to do is I'm going to subtract 1.75 on both sides. Okay. When I do that, I get 0.65x is less than or equal to $8.25. Okay. Now I'm going to go ahead and divide both sides by 0.65. When I do that, I get x is less than or equal to 12.69. However, that really can't be my answer because no taxi cab service is going to charge you for 0.69 of a mile. So I'm going to have to round down. The most amount of miles I can travel without exceeding my limit is going to be 12 miles. So my final answer is Katie can travel 12 miles. Anything past 12 miles, they're going to charge her for a 13th mile. So the most she can travel is 12 miles. Okay, so you have 2 practice problems to try on the back. God bless you and have a good evening.